This is Kendall Bruden, and this is assignment 1 of EEGR 409 C programming applications. And for this project, I have to complete the objectives below, as shown. Declare 3 integer variables and store a number of revolutions for each run. No user input. Declares 1 floating point variable and store the radius of the wheel. Declare 1 floating point variable and store the true distance traveled. Calculate the distance covered for each run. Display the distance covered for each run to 2 decimal places. Calculate and display average distance traveled. Calculate and display encoder error. And calculate and display the percent encoder error. And when I'm done, it should look something like this example. So going into my code, I included the typical libraries stdio.h, math.h, and cmath. I included cmath due to some errors I was getting with using the absolute value and other math functions. But here I declared my variables for each run. The run represents how many revolutions happened within each run. So run 1 had 10 revolutions, the second run had 11 revolutions, the third run had 10 revolutions. And the distance for each run was labeled as dist 1, dist 2, dist 3. The encoder error is just EEGR. The percent encoder error, I just named it printer, just because why not? The average distance, and I have 2 other variables, a floating point variable for the radius, just r, and the true distance traveled as 1354 as given by the example. So the first thing I calculated the distance traveled for each run, and it's very simple. Since we're dealing with revolutions, I used the equation of 2 pi r for the distance traveled by 1 revolution, and just multiplied it by the corresponding revolution. So run distance 1 would have 10, distance 2 has 11, distance 3 has 10. And the next thing I did was calculate the average distance traveled, which is just adding all 3 of the distances and dividing them by 3. And then all I had to do left was calculate the percent encoder error and percent encoder error. And for the encoder error, it's just the absolute value of the average distance traveled minus the true distance, while the percent encoder error is the encoder error divided by the true distance traveled times 100. And the last thing I do was print the results. And I did this in such a way where every print function is represents a line in the display box that's to follow. So each one. So this before. It's a lot easier to see and maintain in this fashion rather than putting it in one giant print function. And I use getChar in order to keep the display box on the screen long enough for me to see everything. So go ahead and run it. And here we have command box that looks exactly like what we had, exactly like the example. And that's it.